My name is Tanya Jackson, Vice President of Operations for Montrose Air Quality Services. I'll be the moderator in this room for today. And our next presentation is by Benjamin Tarshis from Bascom Turner. He's going to be presenting on the Bascom Turner CCD 201 for Method 21 determination of volatile organic compound leaks. Ben is the Chief Strategy and Operations Officer at Bascom Turner Instruments, where he leads and develops overall customer strategy, product launch, and new market entry. Prior to rejoining Bascom Turner, Ben was a consultant at PwC. At PwC, Ben was a founding member of the Workforce of the Future practice and worked with leaders and executive teams to reimagine and implement their overall strategies. Ben lives in Westwood, Massachusetts with his wife and 3 children. They all enjoy hiking, spending time outside his family, and cheering for Ben's hometown, Cincinnati Bengals. Everyone, please welcome.
Thank you very much. Apparently, sound a lot more special on paper. So I'm Ben. I'm the Chief Strategy Officer at Bascom. I'm joined by our colleague Niloy, who's our senior scientist. But before we get into the CCD, we're going to talk a little bit about the CCD. We're going to talk a little bit about who we are as Bascom. We've been around for quite some time, but you might not have heard of us because we've been spending most of our time downstream, and we're going up the oil and gas stack, as it were. We're going to do a little bit of a side-by-side comparison of our CCD to some of the equipment typically used for Method 21 and the midstream for LDAR devices. Share a little bit of feedback from the field from our customers who are using the CCD so far, and go through a couple of use cases, how we calibrate response factors, and what does it look like to service our units in the field, and what are some of our data pull and data streaming requirements. So hopefully this is a two-way presentation. I hate talking out, so if you have any questions, just go ahead and interrupt me, and I might interrupt you back, but I swear we'll get your question. So who are we as Bascom Turner? So we're based in Norwood, Massachusetts. That's in the Boston suburbs. And for over 40 years, we have been making combustible gas indicators primarily for our downstream natural gas utility clients and their survey providers. So our very first unit we built in partnership with Gas Research Institute. It's all the way on the left. That is our gas sensor unit. It's a 50 part per million unit, all the way up to 100% gas. We have thousands still in the field. And our customers really love them, even though we try to get them to switch over. But there's something about that handheld box with the analog switch that they can't just get. They just can't quit it just yet. In the early 90s, we came out with a slightly larger unit called our Gas Ranger. We lovingly call it the Brick. It is also a 50 part per million combustible gas indicator equipped with all other sensors. And again, it is. Customers too. There are still thousands out there. They don't want to let it go. They just love that brick. In the mid 90s, we came across with our very first calibration. So we built this in partnership with Southwest Gas. And one of the issues that they were trying to solve is how do we make calibration easier? How can we make our calibration records easier? So we worked with them, and we now have over 1,000 docking stations out with all of our primary utility customers that help with not just calibrating machines, but record keeping and when the UC comes to town, they're ready to go and can pull off these 5 units and look at their calibration records. In the early 2000s, we changed our form factor a little bit. So this is our handheld gas explorer model, and it's the basis for the unit we're going to talk about a bit. It was a 20 part per million CGI and 20 part per million all the way up to 100% gas. Can be equipped with all those lovely additional sensors, and we've been rolling that out as a customer service alternative. Now and then, our unit, which the CCD is most closely related to, is the Gas Rover. Gas Rover came out in 2008, and at the time, it was the very first FID alternative that was 1 part per million, all the way up to 100% gas. So a lot of our customers in the late 2000s were saying, "What do you mean I don't have to have a Southern Cross flame pack that carries H2 fuel? I can just have and a CGI when in one leaks?" No, you could just use the Gas Rover, and that's really been the source of the technology we're going to talk about with the CCD. The very first company in the downstream space to offer integrated Bluetooth and GPS in our units. So that's been something we've been doing for about 15 plus years now. One of the very first to offer on-unit methane confirmation and detection. So we can detect as little as 50 part per million volume, 1 liter sample of gas on our units in the field. Again, something really valuable for our downstream customers who need to determine, is it swamp gas or is it their gas? We came across, we updated our new model. We got the Rover 2, same form factor, faster design. 2 years ago, we came out with our mobile laser detection option. And then what we're going to talk about today is our CCD 201. How can we further evolve our sensors to not just be methane specific, but to be detect really anything with a hydrocarbon bond. Questions about who we are, anything? We're going to keep going. So what does the CCD look like as you compare it to some of the equipment that's out there? One of the questions that we get asked before we go through that is it a method 21 unit? And yes, the answer is yes. So if you go to method 21 6.1, method 21 does not say these are the types of units that must be used. They say this is the technology that may be used. And we are a catalytic combustion sensor, and that's the very first that is listed is catalytic combustion technology, flame ionization, photoionization, and optical are the method 21 units. So like the FIDs and OGIs that are out there, our CCD can detect a range of VOCs. The first difference that you're going to see is in row 2. Our price point is a little bit different than the equipment that is out there. It's FIDs is 15, 18,000 plus. The cameras are fantastic, but they're a little pricey. We come in just a hair under 6,000. Pound and a half goes on your shoulder. Oops, set it and forget it. It's right in your hand. We have all sorts of wands and hoses that you could like with it. It's no fuel. This is all you need. It operates on 2 C-cell batteries. You're going to get about 10 hours of work at least per day. Unit comes with 2 sets of rechargeable batteries. Our detection range for the VOCs were 0 to 40,000 part per million, 1 ppm resolution. You can use it pretty much. It's not going to be impacted by the environment. Our response time is 0.6 for methane. That's just once it's in the sensor chamber itself. Obviously, the unit response time is going to be, if you've got a 40-foot hose, it's going to take a little bit longer for the sample to travel from the tip to there. We're a class 1, division 1, intrinsically safe. Our warm-up time is right around 1 minute. We have no issue with low humidity or high humidity. Use it in the rain if you want to, but just make sure you don't fall off the ladder. If you're climbing up in about as cold as it can humanly go, be out there and do your work, and about as hot as you can out there and do work. If when Rick makes you work in negative 30 C environments, then maybe it's time to go somewhere else. Who knows? I saw some questions maybe formulating as I go on. Any questions, comments? Use themselves.
I mean, I have one.
Yeah.
Okay, almost every single category, it's a better product, right? So like, why are a lot of people just hearing about it for the first time?
Because it's new, right? It's as oops. Hold on, come on. Here we go. For 40 years, we've been focusing on downstream, and really we put a lot of engineering effort in the last 18 months behind the CCD to adapt our sensor and our software to move it forward. So we are a new entrant to the space, and Montrose and Think and a few others have been the first early adopters, and so that's why it's okay. Go ahead, Neil.
No, I mean, main thing I think was people just didn't do it because FID, when they started in 81, I think that's when they wrote those CCD 21, they had those TVA there. So since it was there, people were just, okay, let's just use the same thing. I don't think there was any technical reason. It's just people were using it because that was there in the first document they wrote.
Yeah. Is there any limitations on if you were going to just look at a natural gas facility, primarily looking at methane, would you use a different instrument than this one particularly, or
if
it doesn't really matter?
If it's a methane only environment, you could use a gas rover, which is going to be calibrated specifically to methane, and it's 1 ppm all the way up to 100% gas. Whereas the CCD is going to flame out. It's a different technology at around 40,000 per million. But
okay.
So certainly.
Thank you.
Questions on the unit and technology? Yes, sir.
How many gases can you calibrate to at once?
Eloy, how many gases can we calibrate to it at
Different
once?
types of gases or different?
for span points. Like,
So at this point, it's two, because our response is linear. It actually makes no difference technically, unless regulation requires we could add that, but technically it makes no, we'll show you data that it makes no difference. But,
The rules require us to go more than 2 points.
yeah,
It's
so,
not how
Yeah.
well your analyzer.
No.
We have to put.
so
Yeah.
that's, see, again, we're new to this space, well,
Yeah.
you can add this, you can do however points you want. We just don't do it because it adds no value to measurement.
Yeah.
So if customer wants it, we can, okay, use your 10 gases, whatever span you want.
As we, yes, again, as we enter this space, we are learning with you and our customers and prospective customers about what makes sense. And when we came out with our calibration procedure, we said, well, when we play lawyer, we don't necessarily interpret it this way, but the reality is. So we were too clever by half in our implementation, so we'll be 1/4 as clever, or maybe 1.5.
But once the way the FIDs and all calibrate, you have to put those things.
Yeah.
in there to pull them in the
Yeah, because
range.
they are not linear.
But since y'all are linear.
Yeah.
Technically, yes, you're right, scientifically you're correct.
Science
These
is-
Korean lawyers are reality of what we deal with.
Yeah.
Yeah, so as I'm saying, we could add that. It will not be a
Yeah.
changing technology, it's just
No,
adding
yeah.
a software to.
Yeah.
Accept those data.
To accept
Yeah,
those
just
data
add the
points.
extra points in there.
Yeah.
You said we could, you say, yes, we will.
It's.
Okay. We will
Yeah.
do it. We will do it.
There we go.
We will do it.
We're getting a nice punch list for our software engineers this week. So,
Yeah. Good.
Coming Q2 by the latest Q3 2023, we'll have these changes done. So Montrose and Think and others have used our units in the field and done some side-by-side testing for us. So I'm gonna speak a little bit on Think's part here, but those who have done the testing and worked for Think, please interrupt me as I go. So side-by-side testing with the CCD and commonly used FID, PIDs. Many environments, hot, cold products and streams, and in all those environments, the CCD perform the same or better than the commonly used FID, PID. So we were worked and tested in isobutylene, ethylene in a cold environment, high gas, methane in hot environments, gasoline, butane. So we were thank you on behalf of Think who ran those tests. Thank you for doing that. If there's anything you'd like to share about that, I'm happy to hear and share with the group.
And we've used it inside. We've primarily used it out in the West Texas with the gas plant. Butane, propane, methane, it's no brainer. The only thing we've been waiting on is for them to get working with League DOS and Guideware and all the other software.
So the one big change that you made that I noticed a
Yes,
huge
sir.
difference in was the probe itself, the size of the tip.
Yep.
So we went from I don't even know what that was,
I think
maybe.
we gave you the original Bell Pro, right? Is that what we gave?
Oh, I'm just talking about the probe.
Oh, yeah.
So it was a much smaller tube and
Yeah.
now I have a much larger tube.
Yeah.
And it works, I'm talking about the metal tube
Yeah.
on the end, works 2 times.
Fantastic.
Yeah,
I'll let Ernie in the machine shop now.
It's faster
Yeah.
than anything I've ever.
Fantastic.
I mean, I was quite impressed with it. Plus, I'm much rather carry around a pound and a half than 5. It's much nicer on the old people.
So when running these side-by-side testing, comparison to the FID, the CCD, how consistent were the readings?
Very, very consistent. Within 2%, and if anything, it was probably, it's a little bit, well, very close, within 2%. And faster. So the response time, the actual time, is pretty amazing. Yeah, really. So typically, most analyzers,
they come out with a response factor.
Yeah.
Based on different chemicals. That's something y'all
We
do.
do. You're like getting to the end of the death. Good answer. That's
Well,
fine.
he's talking about commonality
Yeah.
between district and district. Well, it's all down to the response
Exactly.
factor. So,
You know, we,
whatever he's
we've
looking
got.
And I'm only talking about gas pump, because that's all I've ever used
Yeah.
it in. I've not used it in the chemical plant. I've not used it in different applications. I mean, strictly the stuff that I did was in a gas
Yeah.
plant, and it was pretty amazing.
We can sort of the short answer, and then we'll let Nikolai go through his formula, which is sort of proprietary, but anything that can combust, we can detect. We have response factors developed and confirmed both for about 25 or 30 right out of the book, but if it's new, we can model it and make some adjustments. It's, you know, a little bit science, a little bit art to make sure we can get it right on. So that's a great question. Thank you. Any questions in the back, or should we keep going forward?
Yeah.
All right. So, we talked a little bit about calibration, and we want to talk about how it calibrates now and then certainly what it will be. So right now, we're using a 2-point calibration procedure, 0, and then you get to pre-program to detect 510 or 10,000 BPM methane. But as you can see right here, if you want to calibrate it on 2,000 or 25,000 BPM, you just press the edit button and then you make sure that you put the concentration in correctly. Enter 200,000, you connect to 2,000. It happens, so we just run a new sensor routine and it'll be just fine. But Nikolai, do you want to talk a little bit now about sort of the formula we use for calibration and some of the studies?
Sure. So CCD is based on combustion. So it's basically an oxidation process. You have CH bond with oxygen, it breaks and creates carbon dioxide and water. So it's a linear process. So if you have more carbon, more CH, you get more oxidation, so more energy. So it's theoretically a linear process. So with that, when we made this, we were not sure, but by reading the procedure, it didn't look like we needed to make 3. We went to look at the 1981 method, 21 method. It didn't say that you have multiple points. So we thought, okay, let's make it easier because it's a linear device. You have a 0, and then you choose 1 because it falls on the slope and done with it. So that's the thought. Yes.
So, yeah, so you went to the method 21, but see, the regulations are the ones telling us of several points how to calibrate the analyzer.
Yeah. So
We're
we are
better
learning.
engineers than we are lawyers.
So we are learning. So to show you the proof of this and why we chose this. So this is this device that doesn't have a laser pointer, right?
It does.
Yeah. So this is a device that was calibrated with 10,000 ppm. So we had a 0 and a 10,000 ppm. And then I measured 500, 2,000, 1,500. You can see the response is linear. I did not choose other points. It was only calibrated with this point and 0. And I did the three-point test to look at the precision of it. And you can see that the precision was well within what method 21 tells us to be for all the span ranges. Okay. And just for the heck of it, I also measured ethane and butane. Yeah, that is ethane and butane. And this is our response factor for those. And you can see their precisions were also very good. Even though my calibration was nowhere near the numbers that I'm trying to measure. So that was our scientific thought behind why we chose one. Of course, we will implement and make it three gas, but it's probably not going to improve much in terms of performance. Probably get similar.
We all understand that. We would love those. That's one gas I got to do it, but no, there's some regulations. There's
We get it now. It has been drilled into us since yesterday. We get it. Yes.
Yes, sir.
So does that change the with it, or is that like a soft?
That's a software rollout that we are going to be working on.
We'll probably, yeah, it will be software change. They'll still probably have to enter the number, because we won't know now what's.
Right.
Like, you want 2 or 10 span points and you still
Yeah.
number of span points. you
Yes.
want and put it in.
Yeah, but you will have to input it and just have to input it correctly.
Yeah.
So, so this is one and this is just show, now, I just made it visually look nice where I showed you where the precision lines are to show that all the measurements are. And it looks odd because I'm really going a huge scale and I'm showing you linearly. So it looks like as if the precision is very low there because, you know, it's a linear. I'm trying to put 0 to 25,000 in a linear scale. So things look odd. But in reality, if I zoom in, all measurements would look like this if things were scaled into the precision because they're all well within the precision. And so the, I mean, and we have, now another thing is response factor, because how well does it respond to other gases? So we have a model with which we can predict the response factor based on the chemistry of the gas that you are looking for. And then we have also experimentally verified the model with some of the gases. We did not, like, you know, when I look at the list, there's like hundreds of gases, but they fall under similar categories. So this is a
Go back.
this is a representation.
You used were LEL like 4,000 when you did the test.
No, this is, I did not, this is just, I did not use LEL to do the test. This is just for representation that these are all the LELs of the gases.
Okay.
This was not used to, it was done for 500 ppm or 10,000 ppm, the experimental validation. LEL is because my calculation uses LEL as one of the things in my model, so I put it there. But it provides only information, it has nothing to do with measurement. And this is the well-known way we calculate the response factor, known gas divided by whatever the instrument is. And my understanding is that method 21 says things has to be less than 10 or something, and they are all like within that number. And I don't think that are any different than what other people have, like TVA has. I think the numbers are very similar to TVA. I actually did not put it because I didn't want to put a particular company's number to compare with our numbers. I actually had a chart with all the competitive technologies response factor and our response factor. So they're all very close.
So they gotta be different because.
No.
Technology, yours is
They're different, but
We just care it's less than 10.
yes, that's what I meant. When I say they're similar in the sense they're within the specs. And usually if it's above 10, our sensor will probably not respond to that gas anyway.
Yeah.
So,
That all the ones you currently have response factors for.
yes, because you just don't know which one people run. There is a lot of engineering time to figure that one out.
Yep.
Because some of the gases are toxic. We do not have ability to measure toxic gases in our facility. So those are the things we have to figure out. But we can give a theoretical model, and we are pretty confident that within like 10% of that theoretical model, that's some of it. But then if somebody wants to validate it, we need to do an experiment to figure out how to do an experimental validation of it. But as of now, as long as there is, and it also works for hydrogen, just pure hydrogen. So you don't need like CH bond. You say CH bond, yes, but it will also work if it's just a pure hydrogen. You can also detect. Any questions?
We looked at the response factors that EPA published way back with the OBA 108. Along with the OBA, they also compared to a catalytic combustion. So it was the backrack TLV sniffer, but it's the same technology. If you look at what most of them are doing right now, Thermo basically, for their 2020, didn't go back and do anything. It just said, refer to this,
1000.
refer to the 1000B or the 108, which is what that was.
Any other questions?
Sure. So, it is field equipment. We understand it's field equipment and it's going to be used like field equipment. And we are, got 40 years of our downstream customers using gas explorer 90% of the time, for example, as a gas detector, and the other 10% of the time is gassing. So we've designed our units to be incredibly robust. We've designed them to stay in the field. And so this is a diagram of we take off the front cover, we take off the circuit board, and nearly everything that you might have to change or address in the field, you can do yourself. So the VOC sensor is sitting right there in a sensor block. Take off 2 screws with a Phillips screwdriver, pop it in and run a new sensor routine. If you suck up too much sand or dirt or water, the pump is, where we go? Pump head and pump motor are right there. Those are very easy to change and repair in the field. And, you know, there's the inlet fitting here, this silver inlet there. Again, just pop it off the wrench and you're ready to go. And so we repair a lot of equipment. We work with our customers to empower you to make sure that we put things in the field, not flying on by UPS or FedEx back to us in Boston area. Even the occasional when you need to replace the top and bottom of the instrument case cracks, I can't imagine. It's awesome to crack. So pretty easy change there as well.
Oh, okay.
Never broke.
Falls off of the tower.
So all of our units have in-unit data logging comes standard with Bluetooth and GPS. So on the right-hand side, this is the output file, what it looks like when you want to integrate with leak DOS, guideware, Central, etc. We have successfully worked with the Alliance Software Group to get it onto leak DOS and guideware, so that is ready to go, and we're happy to partner with whoever to make sure that works. That's just a team's call, and just bring everybody together and make sure that we're giving everything that you need, but it's very simple text files, however these come out. Pretty easy to tweak it on the back end. On the left-hand side, this is our own software. So our own software is a piece of software called Data Link for Access, and that can be used to pull readings directly off. So our units store at least 6 months of readings data. The last program now to grab the last 24 calibrations. So what you see right here is sensor sensitivity report from one of our CCD units. And sensor sensitivity is a really effective way to predict sensor life. So any sensor that is going to have a sensitivity and this above 500, you know, it's going to operate just like you. But as you start to see sensors, particularly maybe year 2 or year 3, drifting down, you might want to preemptively change them or not, but whatever, so long as it's within 3 years, we will warrant those sensors. So we have a 3-year warranty on the sensors. The rest of the machine is just pointing. Questions about data and our software itself? Perfect. And then what do you get with it? So when any CCD unit is going to come with the price, you get a case, you get the unit, you get a pack of 5 dust and water block filters there, you get the metal gooseneck probe, you get the hose, the bicycle handle probe. On the right-hand side, this is one of our calibration setups with 0 gas, 2 tanks of gas, 0 gas, and 500 or 10,000 parts per million gas. But again, if you learn more about the regulation, we're going to have to look for a 4 or 6 gas case. All she wrote.
How much are the filters?
The pack of 5 filters, they are $35. That would be for 5.
How long do they last?
Till they look gunky.
It depends on the.
It depends. Everything depends on use, but it's you know, if it's a wet, rainy day and you feel like you're getting mud inside of it, just screw it off, throw it away, and put a new one in.
We have 2 different kinds of filters.
Yep.
So one is more of a dust filter, one is water filter.
So if it's got the white HEPA filter in it, it's a dust filter, so that could be useful, particularly, you know, West Texas. I don't think that we provided our water stopper, but that is an additional.
That's the one that looks like a stone.
There's it's black on the top, black on the bottom, and it's got a water float in there. That's not
Okay,
I'll send
no.
you to.
So I'm talking about,
The one that looks like a stone that's a little bit wide, that's a little
Yes,
bit wider of a
yes.
circle. Yes, that is our dust filter.
okay, so what about the one that's completely empty? It's got a little bitty filter in it.
Yep, again, that is,
Two different filters though, right?
yeah, exactly. They're two different filters.
So
So
what
two are,
What are the purposes?
additional protection is really what their purposes are. So
Okay,
the dust filter, if you are in a sandy desert environment, you might want to add that in addition to this filter. It's gonna just,
oh,
yeah. So for example,
You can put two filters?
you
on
can,
it?
it's all, they all screw and stack on top of each other. So this
So
just.
the water filter,
So this is our standard dust and water filter.
right,
If you're in a desert environment, it might behoove you to put
An
the
additional
the
filter.
additional HEPA filter on top of it. That is something, for example, Southwest Gas uses standard. They do a double filter stack because they're in the desert. It's just.
Good.
Fine particulate does get in and pump heads do not like fine particulate.
How many filters have you tested?
Pardon?
How many filters have you tested? with?
How many filters do we have, Eloy?
So we have tested, I think, 3 filters,
Yeah.
but nobody asked to put 3 filters. so we-
Yeah, exactly. The most practically you might use is 2, right? If you're in a wet environment, you could add an additional water
So
stopper. here.
only issue is the timing. We are well within what we do, here, so even if it slows down, we have to.
Yes, ma'am.
What about drip? What have you seen with drip? Like if you've used it, for the people that have used it, you know?
I've not had it fail to drift. Now, understand that I'm not using this to do method 21. I'm doing this to do comparative monitoring to basically double check on my technicians, but I've gone through the calibration and when I calibrate with 0, 500, 2,000, and 10,000. And when I say I calibrate, I bump test the machine and the machine is spot on. It's closer and more accurate than a 2020 is my experience.
So I have done intensive drift testing, like basically see how same gas I measure over and over 8 hours. I've not done it in a field because I don't know it in the field.
Yeah.
So in the lab I have tested, we have never had one fail that plus minus 10% that is happening. But take it with whatever you want to take because I can only test so many number of devices. But I have not had it fail.
With the amount that this user group calibrates with, given that your multiple calibrations a day, sensor drift should be very minimal. When sensor drift would happen, is typically low battery life. You're just not getting enough pump into the sensor, and that might be happening, but you're going to see it on the machine. So if you keep your batteries charged and your filters clean, drift is going to be very, very minimal.
What gases? How long does one cylinder like that size last you?
We know how long it lasts at our utility customers who are calibrating every 30 days. We use about a half a liter of gas per
So this,
calibration.
just to give a ballpark, this one has 103 liters, that bottle. We use, for calibration, we use from half a liter to a liter. I won't say exactly half a liter. So you take that number and figure out how many calibration you can do with it.
So now we have the little ultra rays and we go through a ton of those size. So I guess we could do the full size.
Yeah, there's no reason, exactly, there's no, these, we tend to store for our customers 103 liter and 617, 620 liter tanks of gas. That is typically what is purchased, but I think, how many thousands of liters of gas do you all go through a day, Rick?
A D-sized cylinder is gonna last a long time.
Yeah. Yes, sir.
So what's the battery life? And then also you have to recalibrate, change batteries.
So you're gonna get about 10 hours of battery life a day. So every unit's gonna come with 2 sets of rechargeable batteries and a battery charger. So so long as you recharge your unit, your batteries, every day, you're gonna be just fine. We also have some in-vehicle charging options available. Happy to discuss, share that later if you're very much much a field operation. I'm going to give me play lawyer versus at method 21. If you change batteries, you should not have to recalibrate. That is our understanding of laws, but I don't want to overspeak for what a specific state or local regulation could be.
That's fine.
You'll be speaking for your instrument.
Yeah, exactly.
Yeah, so-
Speaking for our instrument, you'll be fine.
Checking for our instrument, battery change would not require you to do recalibration.
Okay.
But my understanding is that method 21 requires to calibrate every day. That should.
Yep.
Yeah.
So.
I was supposed to think, hey, we get to the site, we didn't charge it.
Yeah.
It runs for 3 hours and we got.
It should be okay.
Should be
That
fine.
should not be a problem.
5 minutes.
Okay, thank you.
That 10-hour battery life for both sets or like one?
Two C cells, so you get, as long as they're charged, you're 20 hours.
What is the overall life?
The overall life of the battery itself, at least 2 years.
And the cost of those is
$40.
So this is currently, it communicates with Skybridge, with Lake Dust, right?
Yep.
And I may have missed this part, but is this something that can be put into use currently for method 21?
Yes.
It has approval, someone said, this is
So,
good to go?
so
Who's the guinea pig?
our intern, so, I mean.
It meets all of the
It meets all the
requirements,
method 21 requirements. It's, again, our interpretation of method 21, there is no specific instrument that is approved for method 21. Our technology meets all the requirements and then some. There might be site-specific requirements that it does not meet because the site might require an FID.
There may be some consent decrees.
Yeah. Yeah, but we have done a series of crosswalks with section 6.1 in our technology. And we exceed the requirements of method 21, section 6.1 by more than a little bit in all nine plus categories.
What's it weigh?
1.5 pounds.
That's a seller.
I mean, you can pick it up.
Yeah.
Yeah.
Exactly. They all need the red, black, and gray. They all weigh the same form factor.
I bench press only the buck.
So y'all tore out scene is all, we part because like you talk back go do a reading.
Yeah.
Yeah, sit there and wait slowly go back. So we know everyone. Back where one time was used, if there's specific gas,
Yeah.
the FID or PID would.
Yeah. Very proud. It's, once it's in the combustion chamber, it's less than a second. 26 seconds. Does he answer? I think maybe time for one more question, if there is.
Yeah.
Okay.
What's the rate number?
0.5 liters.
Everyone's whipping out method 21 questions right now.
Oh, yeah, these are all.
We looked at those to make sure it matches those numbers.
What's the delivery time?
Under 200 units, 8 weeks. If it's more than 200 units, I've set aside 230 weeks a day. How many times, we gotta look at what the lead time on broadboards is from Taiwan. So okay. We got 200 circuit boards set aside.
Okay.
Thank you, made a few sales today. So, okay, well, thank you so much.
Thank you very much.
Where do you guys use it?
Our OGI team uses it
Okay.
when they're doing their inspections.